So the last thing we talked about was the fact that a greatest common factor doesn't necessarily have to be a monomial. We could take out a binomial. So we looked at this example here where there's two terms, and these two terms had something in common, greatest common factor, 2r plus 1. And we were able to factor that out and see what was left, just like we did with our monomials. So if we look at So if we look at any of these problems here, they look like they're set up kind of funny. You don't necessarily see a problem like that all by itself, except for on this homework assignment. This is really what we're doing is we're starting at the bottom of our longest problems and just working our way back to the top. So we want to factor completely or factor using a greatest common factor in these problems. So if I look at A, again, there are two terms here. This is a term, and this is a term. There's only two terms. What do those two terms have in common? 4x plus 1. So if it's in common, it means I can factor it out, because it's in both of my terms. So my greatest common factor here is 4x plus 1. When I factor it out of my first term, what's left? 2x. So when I factor it out of the second term, I'm left with, and you got to take that sign there, so minus 3. So it's just like our regular greatest common factor, where when we divide it out, whatever we're left with, that builds our second set of parentheses. Same thing happens here. So if I look at example B, again, there's only two terms there. What do those two terms have in common? X plus 7. They have the binomial x plus 7. So I'm going to factor out my greatest common factor here is x plus 7. And if I take x plus 7 out of my first term, what's left? 3. If I take it out of the second term, plus 5y. Any questions so far? Okay, so for C, we have 6a times 2b minus 3 minus 2b minus 3. So again, there's two terms there. What do those two terms have in common? 2b minus 3. They both have that binomial 2b minus 3. So after we decide there's a greatest common factor, we're going to take it out of both of those terms. We're going to divide it from both of those terms. So if I take the 2b minus 3 just from this first term, what's going to be left over? So I take that out, I have 6a. But what happens when I take 2b minus 3 out of the second term? Minus 1. So if you ever take a factor, you ever factor something out completely, there's always a 1 in its place. Nothing just goes away. Because if I left this answer like this, it would never check. Because in order to check these, you just multiply them back out and make sure. These ones are a little difficult because you have to multiply this out, make sure you got the same things both times. But if I just had this, there's no way I'm going to get back all the terms that are up there. So if you ever factor out a term completely, there's always a 1 in its place. And another way we can really see that is if I divide this by 2b minus 3, if I divide anything by itself, other than 0, anything by itself, it's always 1. 2 over 2, 5 over 5, x over x, they're all 1. So if I have 2b minus 3 and I divide it by 2b minus 3, I get 1. And in this case, because I had that negative sign, b minus 1. And again, you could check these. It would require that you actually multiply back out the problem and the answer. Except for this homework, you're never going to have a problem that looks like this. This is, again, kind of the last step in the problems we're going to do today. Now, if I look at D, right now I have actually 3 terms in D. All these other problems had 2 terms. Does anyone have a way that we could possibly make this problem right here into 2 terms instead of 3? Devin. That would actually make it 4 terms. It's a good thought, though. We're trying to get fewer terms. Look at the setups of all these other ones. What's not in this one? It was in all of these problems. Parentheses. Yeah. And can I just put parentheses? The answer in this problem is yes. The reason being, this is a plus sign. So if I put parentheses, that really means there's just a positive 1 out front. That's okay. If this was a minus sign right here, you couldn't just put parentheses, because then you're saying distribute the negative, which we looked at back in chapter 5. But because that's a plus, you're okay to put parentheses around those. It's not going to change the value of this problem, but it gives us back to that form of the others where you have just 2 terms. So if I put parentheses around that x plus 4, what do these 2 terms have in common? X plus 4. And if I factor x plus 4 from my first term, what's left over? X. If I factor x plus 4 from x plus 4, what's left over? 1. If you take a factor out completely, there's always a 1 placeholder there. You can also see that by dividing. And you could always write out this step where you divide by your x plus 4s. Divided by itself gives us 1. This time it's plus 1 because there was a plus in front of the parentheses. Questions? Dennis. So when you factor, do you understand where we see we're going to factor out the x plus 4? They both have an x plus 4. So if you take the x plus 4 from this first term, that's where we're getting the x from. If you take the x plus 4 from this term, there's really a 1 out front. So that's where the plus 1 comes from. Like this, where it was just a minus sign, you can always put a 1 in. So if we're factoring this out completely, that's where we get the minus 1. On the other examples, there was actually something in front. So whatever was in front of the parentheses is what's really going down here. So there's the 3 and the 5y, for example. They're coming from what's in front of the parentheses. Here's our 6a. This minus sign is really a minus 1. If you want, you could put a 1 in front of the parentheses. Doesn't change it. So there's our x, and there's our plus 1. Make sense? All right, so our last example here, 2x times x minus 9 and 3 times x plus 9. What do these 2 terms have in common? I gotta vote for x, I gotta vote for nothing. Sticking to nothing. Factor-wise, so yes, both terms there do have an x in them. But factor-wise, do they have anything that's the same? No. When you're talking about factoring out a binomial, so it's a set of parentheses, you have to have an exact match. I always like to say you can't cherry pick. You can't say, well, they both have an x, so I'm going to just pull the x out of the parentheses. If you're trying to factor out a binomial, a set of parentheses, you have to have an exact match. So this is pretty close. You have an x minus 9, you have an x plus 9, but they're not the same. So these 2 terms really have nothing in common, nothing that could be factored out. So this problem is prime, or not factorable. Now, again, you're not going to see problems except for on your homework that are already set up like this. So it's going to be your job to make sure maybe you made a sign mistake somewhere further up, to check those things. But if it doesn't work, this is where you'd say a problem is prime. So go ahead, let's just add one more to try before we go on, because you have to know how to do this or you won't be able to do the next step above it. So let's take 3y times y plus 4. Go ahead and factor that one. 3y times y plus 4 minus 2 times y plus 4. right, who's got an answer for me? Napoleon, right? Yeah. What do you got? Y plus 4 was my GCF. When I factored it out, I'm left with 3y minus 2. Great. And just a note, as we get going into the next step, this is the exact same answer as 3y minus 2, y plus 4. Whenever you're factoring, the order of your factors doesn't matter. I always write the GCF first because really the concept we're coming from is that we have a greatest common factor we're bringing out front. But some people look at this and say, okay, I'm going to build that factor 3y minus 2 first and then copy the one that's in common. That's okay. The order of factors never matters because it's all multiplication, which order doesn't matter. So any questions on factoring out a GCF that's a binomial? So this is the last step in our longest problems. What we're going to do today is we're going to add the one step above it, the one skill above that, and then on Monday we're going to put all of these things together. That's why we start at the bottom, just piece by piece. All right, so where we're going to take this is what's called factoring by grouping. And to factor by grouping, you always have to have 4 terms. So the only time you factor by grouping is if you have 4 terms. That's how you know to factor by grouping. There's 4 terms in your problem. So what we're going to do is we're going to take our problem and we're going to split it into 2 groups. We're going to put the first 2 terms together and we're going to put the second 2 terms together. And then we're going to pretend that they're 2 totally separate problems. And we're going to take a greatest common factor from each of those 2 little problems we set up. And what's going to happen when we do that is it's going to turn into something that looks just like this. And then we go back, we take out the common binomial. So if I look at this problem here, it says factor. Just in general it says factor, which that's how it's going to be like on a quiz on a test. The way I know to use grouping is there's 4 terms. So I have 1, 2, 3, 4 terms. That's how I know to group. What I'm going to do is I'm going to take those 4 terms and I'm going to split them in 2. Now some people put brackets or parentheses around them. I prefer not to do that because then it looks like you're already creating factors. So whenever you see me factor by grouping, I'm just going to draw this little squiggly line down the middle to break it in half. Make it 2 problems. The important thing here is that whatever sign was with this 3rd term stays with that term. So you don't want to cut it off between the plus and the 3x. So now what we do is we've created 2 groups. So I have a group on the left and I have a group on the right. And I want to take a greatest common factor from each individual group. So we're no longer looking at the big problem. We're looking at 2 smaller problems. Ayana.
Will you ever switch it? Because I see you broke it down in the middle. Will you ever switch them to where like the xy plus 3x?
You could. It will work out to be exactly the same.
Okay.
Yes. You don't have to in this problem, but you could. So my first group is xy minus 5y. What's the greatest common factor for those 2 terms? What do they have in common? Y. So in that group, I'm going to factor out y. So in this group, my GCF is y. And when I factor it out, going back to Wednesday's class, I'm going to get x minus 5. So now we're going to put that on the back burner, and we're going to pretend that the second group is a problem all by itself. So I'm looking for a greatest common factor for 3x minus 15. 3. I can divide them both by 3. So I'm going to factor out 3. Now, it's really helpful to have a sign. Do you think we're going to take out a positive 3 or a negative 3? Positive 3. You told me 3. 3 is the greatest common factor. So it's very helpful to have the sign there. So it's a positive 3 because sometimes we use a negative GCF. And let's see what happens when I factor a 3 from that group. So I divide both those by 3, and I'm left with x minus 5. And look what happened. What do we have in common to group 1 and group 2? X minus 5. We're back to the problems we just did. So after you factor a GCF in each group, you should have that matching binomial. If you don't, it's either not factorable or you made a mistake somewhere. But once you have that common factor, there's one more step. So it's really 2 steps. You factor the groups, And then just like the problems above, the GCF to both of my groups is x minus 5. Dennis, I'm going to put you on the spot here. So what goes in my second set of parentheses? You got it. The y comes from the y here plus 3. Perfect. And that's my final answer. And if you wanted to check it, all you'd have to do is FOIL this back out and make sure you've got the same terms that were in your problem. They may not be in the same order, but they should all be there. Questions? We have a bunch more of these, but any questions so far? Anna? Yes. Again, not necessarily the same order, but all the terms will be there. So B. Now, before I start one of these problems, what I should really be looking for is a greatest common factor for the whole problem. And then I'll go down to my next method, which is for 4 terms grouping. So if I look at B, y cubed plus 6y squared plus 4y plus 24, do I have a greatest common factor to the whole problem? First thing to look for. No. Okay. Then the way you always tell where to go next in terms of factoring once we start adding on more and more methods is how many terms you have. That's how you determine what method to use from a greatest common factor. So 4 terms, grouping. 4 terms, we're going to go ahead and split this in half. And now I've got my 2 groups, and I want a GCF for each one. So my first group is y cubed plus 6y squared. What's my greatest common factor in that group? Y squared. So they both have y's. So I can actually take out 2 because that second term has the fewest, which is y squared. I'm going to factor that out. I'm going to be left with y plus 6. Now, if everything goes according to plan, we should find another y plus 6 in that second group. If we don't, either something's wrong or it's not factorable. So my second group is 4y plus 24. What's my greatest common factor? 4. And you just said 4. 4 works, so we're going to assume it's a positive 4 here. And we'll see somewhere it's not always positive. And that leaves me with y plus 6. So we're not quite done yet. This is the part where you can start getting excited. Looks like it's all going to work out because we got that y plus 6 in both groups. Last step, you've got to factor out the GCF, which is y plus 6. And what's going in my second factor? Y squared plus 4. And the other reason we can't stop right here, factoring always sets up a multiplication problem. This isn't multiplication, it's addition between 2 terms. So I've got to make sure you get to this extra step so you really have a multiplication problem. So next, C is AB plus 5A minus B minus 5. Do I have a greatest common factor to the whole problem? First thing you always look for. No, they don't have any numerical factor in common other than 1. They don't all have the same variables. So the next thing you should always do when your directions are factor is count your terms. So we're going to have 4 different methods all together after GCF. It's all based on how many terms you have. We've got 4 terms, that tells me grouping, because I can split them up 2 and 2. Now this is where you have to be careful when you do your split though, that you make sure that your negative sign stays over here with the B. So now I've got my 2 groups. I've got a group on the left, group on the right. So what's the greatest common factor in my first group? A. So I'm going to factor out an A. Divide these both by A. And get B plus 5. So what should happen, if I'm going to be able to factor, I should be able to get B plus 5 out of that second group, where right now I have a negative B minus 5. GCF is negative 1. How'd you get negative 1, Adam? It's correct. Just because it works. So we use the positive. Rob?
Because negative, 5 is negative, you gotta make it positive.
5 is negative, you gotta make it positive, and what else?
Does negative repeat?
Yeah, both of them. So the signs, one of the things you look for in terms of, do I have to take out a positive GCF or a negative GCF? Your signs are completely backwards. I want both signs, if I'm gonna match positive, positive, both signs are negative. Completely backwards of what I want. That's the first sign to use a negative GCF. The second thing, does anyone remember what we talked about last time when we just look at a problem, how do we know we might use a negative greatest common factor? Yeah, the first term is negative. So when you look at a group and the first term is negative, it's a 95% chance you're going to be taking out a negative greatest common factor. If it doesn't start with a negative, probably don't have to. And you might mess something up otherwise, but if this starts with a negative, good chance you need a negative greatest common factor. And then my only common factor to a b and a 5 is 1. This is that instance where we care that 1 is a common factor for any polynomial, because we have to take something out. We need something in front of those parentheses. In this case, it's a negative, so we can switch the signs. And the only common factor between b and 5 is 1. You do want to put the 1 in front of your parentheses when it's your only common factor. So that gives me b plus 5. Be extra careful with those negative GCFs to make sure all your signs match up. And then my last step, greatest common factor. Got that b plus 5 to match. And then my second factor is a minus 1. Again, if you write a minus 1, b plus 5, it's the same answer. Questions? All right, D. Anyone have a place they want to start problem D? What do you say, Tiffany? Factor out of 6. We have a greatest common factor to the whole problem this time. So before we do anything else, you should always start with the greatest common factor. Not that you can't finish with 1, but people usually don't remember to find it at the end. So first thing, look at your problem, look for a greatest common factor. In this case, there is a GCF to the whole problem, and that's a 6. So I'm going to have 6, and then go through and divide each term by 6. So I'm going to have a squared b squared plus a squared minus 3b squared minus 3. Now, on Wednesday, that's all we did. We said greatest common factor, it's done. But now we have more factoring methods. So now what we're going to do is we're going to look at the parentheses and try to factor them by another method. So the 6 is going to hang out front. The 6 has to be out front in your final answer. I'm okay if you don't necessarily write in every step if it gets too messy, but you've got to make sure when it comes down to the end that 6 is out front. But if I look at what's in the parentheses now, I see that I have 4 terms. It's my indication I'm going to try to factor by grouping. So the 6 is just hanging out front. And I may even switch, I'm going to switch to square brackets, which mathematically are the same as parentheses. But they just give me a little bit more separation that, okay, the 6 really isn't doing anything in this problem anymore. It's just hanging out front. Everything else that I work out is totally independent of that 6. So I'm going to take my 4 terms there and break them up. Again, 6 is on the back burner. Not doing anything with the 6, it's just coming down. So my first group is a squared b squared plus a squared. What's the greatest common factor there? A squared. So we're going to factor out an a squared. And if I divide that from each of the terms, I'm going to be left with b squared. And what's the second term? 1. So b squared plus 1. What's that? Positive 1. Yep. Absolutely. Okay, so my second group is negative 3b squared minus 3. Any ideas for my greatest common factor there? Negative 3. So, good indication we're going to use a negative. It starts with negative 3. So when your second group starts with a negative, you usually use the negative greatest common factor. We're also trying to switch the signs from negative, negative to positive, positive. So if I factor out a negative 3, be extra careful with those signs. I get b squared plus 1. And I have one last step to build the answer in my brackets here. What do you got, Devin? Factor out the b squared plus 1. So looking at my grouping steps, I'm going to factor out the b squared plus 1. Again, the 6 is really just going down every step. It's not going into any sets of parentheses. It's just carrying out front. And then what's going into my second factor here? A squared minus 3. Questions? Hang on. Yes, yeah. Just having the 6 against the parentheses is the same. I just keep the brackets there to make sure the 6 doesn't try to like leak into the groups somehow. But yes, you don't need the brackets at that stage. It's a good question. Any other questions? All right, I have 2 questions for you then. Where do you start every single factoring problem ever? Rob. GCF, which is our greatest common factor. And then my second question, what about a polynomial would lead you to try factoring by grouping? 4 terms. Questions? All right, we're going to end today with a little activity then that takes us into Monday. So this is from 6263. If you don't have your guide notes printed, you're just going to have to copy like you would regular notes. And hopefully this weekend get them printed. Again, if you really have trouble, you can't get to a printer, if you let me know, I can bring you a copy. I'm just not going to do a copy for everybody. The print shop would hate me. So what we're actually going to do right now, we're going to skip those first 2 problems. We're going to look at this table here. This is the last skill you need to be able to factor trinomials, which is putting everything we've done together. So I'm going to give you, after I show you what to do, about 5 minutes to see if you can, and you feel free to work with the people around you, see if you can fill in the rest of the table. So what we're trying to do here, each row of this is a separate problem. The first row says, I need to find a pair of numbers that multiplies to 20, and that same pair of numbers adds to 9. So I need 2 numbers that multiply to 20, 5 and 4. 5 and 4. Yes, 5 and 4. Think about it. What's 5 times 4? What's 5 plus 4? 9. It meets both those conditions. Now, it's not always that easy, especially when you start having to play with the signs. So what you should always do is focus on the number you're multiplying to. There's a finite number of ways to multiply to 20. So if you think about it, 20 is 1 times 20. 1 in the number is always a factor. 2 times 10, or 4 times 5. Those are the only 3 possibilities that could work. Now again, you may need to move signs around. They're not always going to be positive. But after you see all the different ways you can multiply to your number, then start eliminating pairs based on your second criteria, your add to. So like I know 1 and 20 could never give me 9. I know 2 and 10 could never give me 9. 4 and 5 do work. So I'm going to actually skip the next one. You can do the next one. The positives are the easy ones. See, negative 30 and 13. So I'm trying to multiply to negative 30, add to 13. The place to always start those is with the number you're multiplying to, 30. And if you're not sure, list every way you could possibly multiply to 30. So I have 1 and 30. What's another way I could multiply to 30? 2 and 15. How else can I multiply to 30? Just one more. 5 and 6. So those are all the factors of 30. There's only 4 possible ways I could ever multiply to 30. Is that a hand, DeAndre, or a stretch? No. Okay. So now I need to look at the second condition. It needs to add to a positive 13. It needs to multiply to a negative 30. So now I have to think about signs. If I'm multiplying to a negative number, one's negative, one's positive. It has to be that way. So we're going for 3 and 10? Okay, make your signs work. I need to multiply to a negative 30, add to a positive 13. What do you say, Napoleon? It's a very tempting pair, 3 and 10, to make 13, but I can never get my signs to work. If I'm going for positive 13, they both have to be positive. It's never going to give me negative 30. So Napoleon, you said instead we're going to do 15 and negative 2. They multiply to negative 30, but if you do 15 minus 2, you get your 13. So take a couple minutes. Again, you may talk to the people around you. Try to fill in the rest of that table. See if you can find pairs that multiply to the number in the first column, add to the number in the second column. If you're getting stuck, look at your factors. Okay, so who's got a pair for me for 10 and 7? Positive 5, positive 2. How about my negative 12, negative 4? You know, what do you got? Negative 6, positive 2. Now, the order in which you put these doesn't matter. If you put 2 and then negative 6, when we get to the problems, it's not going to matter either. Order doesn't matter. Signs do. 60 and 19. DeAndre. 15 and 4. Sometimes you've got to look a little further if those pairs are unfamiliar. 15 and 4, great. 16, negative 8. Adam. Negative 4, negative 4. Sometimes it's the same number twice. And then negative 9, negative 6. Negative 3, positive 3. So if I have a negative 3 and a positive 3, what do I get when I multiply them? Negative 9. What do I get when I add them? 0. Okay, so that only fit one condition. So the next option, negative 3, negative 3. What do I get when I multiply negative 3 times negative 3? Negative times negative? Positive. All right, that didn't work. If this happens in a problem, you'd be prime. This is when you get a prime factoring problem, when that pair doesn't work. But you have to be really careful because it looks like that should work. But you're never going to be able to keep both conditions. Very similarly, this looks like maybe it should be 10 and 3. But then you see 10 and 3 doesn't work. Don't give up there. You have to exhaust all possibilities. Sometimes something else works. So your homework